Hi everyone, this is Mr. Mohammed. Today we're going to talk about the infinite geometric series and its convergence. And the theorem says it's if a geometric series converges if only r is between -1 and 1. So any value between -1 and 1, of course excluding -1 and 1 themselves. So if it converges, if it does, then actually we can find the sum of the geometric series using this formula right here. So let's take a look at one of the examples. So I have summation from n equals 0 to infinity of 1 over 5 to the power n. As you can see, the first term, a1, equals 1 over 5 to the power n. And n starts from 0, so that's going to be to the power 0. So the first term becomes 1. And r is 1 over 5. And as you see, 1 over 5 lies between -1 and 1, so that's okay. And after you know that, you can always find the sum. So the sum from n equals 0 to infinity of 1 over 5 to the n should be the first term, a1, over 1 minus the common ratio. That's equal to a1, which is the first term is 1. 1 minus 1 over 5. Simplifying this, it's going to be 1 minus 4. It's going to be 1 over 4 over 5, which is 5 over 4. So the summation from n equals to 0 to infinity of an was equal to 5 over 4. So if you add all these terms from 1 to infinity, you're going to get the sum of 5 over 4. Because as you can see, the 1 over 5 is a fraction, and the more you put power on it, the smaller it's going to get. So it converges to 5 over 4. So this one converges to 5 over 4. One more example. I have a series that starts from n equals 3 to infinity, 5 times 2 over 3 to the power n minus 5. And one of the properties of the summation is we can take any constant value outside the summation, so it becomes 5 sum of n equals 3 to infinity 2 over 3 to the power n minus 1. So you just want to find the sum of this series. So you're going to add 5 times all those terms, which is it's not going to be a problem. So r is 2 over 3, and that number 2 over 3 lies between -1 and 1, so it's an okay. So it converges. So to find the sum from n equals 3 to infinity of 2 over 3 to the power n minus 1, it will be the first term over 1 minus the common ratio. And we can easily go ahead and find the first term, a1, by finding at n equals 3. So it's going to be n equals 3. So a1 is going to be 3 minus 1, which is 2. So a1 equals 4 over 9. So going back to the equation, we can write it like this. So the sum from n equals to 3 to infinity of 2 over 3 power n minus 1 becomes 4 over 9 over 1 minus r. And r, of course, is 2 over 3. So it's going to be 4 over 9 divided by 1 minus 1. 2 over 3 is going to be 1 over 3. And after a little simplification, it will be 4 over 3. But we don't forget that we had 5 times that series. So this series only converges to 4 over 3. But if I want to find the whole expression, it will be from n equals 3 to infinity 5 times 2 over 3 power n minus 1 equals to 5 times 4 over 3, which is going to be 5 times 4 is 20 over 3. So this series converges, and it converges to 20 over 3. And that's how we do that. One last example I have, it's a little tricky because the way you look at it is you have two n's, n plus 1 in the numerator and n in the denominator. And a little trick that we can do is manipulate the function a little bit by making it look like this. Pi to the power n plus 1 can be written as pi to the power n times pi to the power 1, because when you multiply, you add the powers. Okay? You add the exponent n plus 1 becomes n plus 1. And here it's going to be 6 power n. Okay? And also, pi is a constant, so you can take it outside, and then you write the function again, n equal 1 to infinity pi power n over 6 power n. But then again, you have two powers, two n's, that's not pretty. So what you can do is, you can combine them because both of them are to the power n, so it can look something like this, n equal 1 to infinity pi over 6 all to the power n, which is the same thing, because when you are going to raise it to the power n, pi is going to be raised to the power n, 6 raised to the power n, so technically you didn't do anything wrong. Alright, so next, after that, you know that pi over 6 is your r, this is your r, and you need to know if this is between -1 and 1. Well, obviously, pi is almost 3.14, and when you divide this by 6, you get something less than 1. Okay, so r actually is in the range from -1 to 1. So it converges, so this one converges. We just need to find what the sum is. The first thing you need to know about the sum is the first term, which is at n equal 1. So at n equal to 1, so it's going to be pi over 6 times pi, that's pi squared over 6. But I'm not going to bother with this pi, so I'm going to leave it at the end. So at n equal to 1, so a1 is pi over 6. So the sum from n equal 1 to infinity, pi over n plus 1 over 6 to the n will be pi times a1, which is pi over 6, over 1 minus r, which is pi over 6. So after some simplification, or using the calculator, you can just plug all of this into the calculator. You're going to get 3.45, approximately, of course. Okay, so this series converges, and it converges to 3.45. So if you keep adding all those terms from n equal 1 to infinity, at the end of the day, you're going to end up with an approximate sum of 3.45. And that's how you tell whether or not a geometric series converges or diverges. But if it does, you can go ahead and find the sum. All right. One more example before I just leave this topic is, how about this sequence? If a sequence looks like this, something like that, -2 plus 2 minus 2 plus 2, and it actually keeps going that way. This series, is it convergent? Is it divergent? As you can see, that it's never going to settle down. And you can have the partial sums, and if you look at it, -2 plus 2 is 0, and the next term will be 0 minus 2, which is minus 2, then minus 2 plus 2, which is 0. So this function actually oscillates between 0 and minus 2 forever. So basically this is a divergent series, and it has no sum. So in other words, you can say it has no sum. Okay, and that's how we do that.